Hey, good morning, guys, or maybe good afternoon when I'm catching you on this day. But we have made it to day 6. Hopefully, you've had a chance to uh, knock out your quiz. Hopefully, you had a chance to do that. That happened on day 5. We know anytime we get to day 5 of a chapter, we always got a quiz that follows. But today we get to talk about my favorite kind of transformation, and it is the fourth and final kind of transformation, which a lot of you guys really have seemed to actually like these. So some of you may be sad to hear that, but we're going to be talking about a dilation. So a dilation. So in this lesson, we're going to learn how to use a scale factor, whatever that is, to make a larger or smaller copy of a figure. So actually, we're going to start. Check this out. We're going to start changing the size of our shapes. That's something we haven't done yet. That is similar. That word, guys, I can't stress enough. Very important, especially for future chapters. You're going to be hearing similar a lot in future chapters. But let's see exactly what a dilation is. So a dilation, that is just a transformation that reduces or enlarges a figure. So it either makes a figure larger or smaller. The image is still similar. We'll talk about what that means in a second. We oftentimes think of this as the widening of an object, such as the pupil of an eye. You ever gone to an eye doctor and they put those droplets in your eye and your eye expands? The pupil expands out to where it covers everything. That's kind of what we're talking about here. Now, what do we mean by similar? The shapes stay similar. Well, similar, and again, the start, very, very important. Similar is whenever two figures are not the same size, but are the same shape. When they're not the same size, but they are the same shape. So a smaller or bigger shape, pretty much. Now, how do we make these smaller or bigger shapes? Well, that's all based off the scale factor. So a scale factor, which sometimes, guys, we're going to represent with SF for scale factor. It's a ratio, so either a fraction or written as an actual literal ratio with a colon, that way or that way, of a corresponding parts of two figures that are similar. So we can use a scale factor to make a larger or smaller copy that is similar. So in other words, this tells us if we're this much bigger or this much smaller. Okay. So here's a little bit more vocab. A dilation is an enlargement. So that's when a figure increases in size. A reduction, so enlargement, reduction is when it decreases. I'll do orange for enlargement. Increases. Big thing, a dilation is not isometry. Why? Why is a dilation not isometry? Oh, that's because the size has been changed. We know with isometry, size and shape stay the same. So let's look at some examples, guys. So on these three, and actually, I don't like the way number 2 printed. You can't really tell what this smaller figure is in there. But for these two right here, 1 and 3, the solid line figure is a dilation of the dashed figure. So what that means is, that means the dashed figure is the OG. It's the original. I just misspelled original. My apologies. And the filled in, or solid, is the dilation. Oh my goodness, I can't spell. I'm not an English teacher. Let me rewrite that. It's a dilation. Yep. So dashed is the original, filled in is the dilation, is the change. So look at number 1. So here's our original. this triangle. And here's the dilation, what it became. So guys, are you thinking, is this going to be an enlargement or a reduction of this original triangle? I mean, a lot of you guys can easily tell this is going to be a reduction. So now that we know it's a reduction, we've told that here. Now we've got to tell what the scale factor is. So how much did it change by? And remember, scale factor is a ratio. It's going to involve two numbers. And in this case, it's going to involve the two sides or pieces of the triangle that we know. Check it out. So let's look at, we always look at the original first. So the original, the OG, we see that was 15. And then our ratio, so there's the original. Here's the dilation. Comes second. And so the dilation is 5. And now normally we're fine if this is our scale factor, right? 15 to 5. But this reduces. This ratio we know reduces. 15 to 5. What would that actually be? Let's divide. 15 divided by 3. Wouldn't that end up being, or I'm sorry, 15 divided by 5. Wouldn't that end up being, you can divide that by 5. Divide that by 5. That ended up being 3 over 1. Okay. So our scale factor is really 3 to 1. Our original was 3 times bigger than the dilation. Let's get number 3 together. Here's the original. Oh, wait, I'm sorry. Let's start off. Do we have an enlargement or a reduction? Well, here's the original. And then here's the dilation. So I'm thinking we're probably all in agreement. This is an enlargement. Pretty clearly that's an enlargement. So now for the scale factor. Here's our original, 3.5. And we can see that the dilation, this side became, we gotta have the same sides here to compare. That's 3.5, it became 14. So let's see what this kind of ratio is looking like. Let's turn it into a fraction. So 3.5 over 14. Try typing that into your calculator. 3.5 divided by 14. 0.25. Hey, we know that is. Math, inner. Hey, that's 1/4. So our scale factor, this is a 1 to 4 scale factor. In other words, we enlarged this shape by 4 times the original. Yep, about 4 times the original there. Nice, and so we've got that. Any questions so far? Hopefully not. Now, let's do some easy ones here, guys. So we're going to assume that we're given 2 points here. Dilation has a center of 0, 0. So in other words, we know these points are based around the origin. We're going to find the image of each point for the given scale factor. So what they gave us here, 7 is our scale factor. We know that's a 1 to 7, 1 to 7 scale factor. And then over here, our original was 1. We're going to 1.2. So if 1 was our original, looks like scale factor of 7, scale factor of 1.2. So I'm thinking both these are going to be enlargement. I bet you guys are in agreement there. Both these are going to be enlargement. And so if that's the case, we know we're multiplying by 7. If it's an enlargement, that's multiplication. And really, either way, it's multiplication. It's just sometimes you're multiplying by a number smaller than 1. So we take 3 and 4, and we multiply both those points by 7. So 3, I'll write our answer in red. 3 times 7 would be 21, and 4 times 7 would be 28. And that is our new point. That would be X apostrophe. We originally had X. This is X apostrophe. So try number 2 for me, guys. we know that our scale factor is 1.2. So go ahead and apply that to both those. What will be our new P, our point P here? Take a second to find out. All right, so we multiply both these by 1.2, and I got that our new point P that's been dilated is negative 3.6 and positive 6. So really, this is just multiplying and adjusting our points by a scale factor, dilating them, kind of like a pupil. Okay, so this is the end of part 1. We'll jump to the next page to start our last part, part 2. Thank you.